In this video clip, we will look at the graph of f of x equals tangent x. When x choose the different values, x stands for angle here, so we will see tangent x choose what kind of value. First, we like to see the value x. If you plug in here, is pi over 3. Pi over 3 is 60 degrees. Pi is 180 divided by 3. So it's 60 degrees. Okay? So when this angle is 60 degrees, or when the length of the arc is pi over 3, this red part. Okay? Or from 0 to pi over 3, this line segment from 0 to pi over 3. So this line segment from 0 to pi over 3 is actually equals the length of the arc. When x equals pi over 3, you have a value y is this high, which is radical 3. Okay? Graphically, you can see here is 60 degrees, here will be 30, and this is 90 degrees, okay? This is 90 degrees, all right? So, then you will have a 1 here, because that's the radius of the union circle. Since this is 30, then this opposite side of 30 degrees is 1, then the hypotenuse will be 2. And then this leg has to be radical 3, is because radical 3 squared is 3, plus 1 squared is 1, which gives us 4. And then this hypotenuse is 2. 2 squared is 4. So graphically, we know this line segment, vertical line, is actually the value of tangent. So that's why we call this is tangent line. Okay, tangent line. So when x is pi over 3, we have a value y is this high. Okay, and then graphically, that was for graphically. On a table, sine pi over 3, sine pi over 3 is radical 3 over 2. We know that. And cosine pi over 3 is 1/2. You divide those two, you cancel both. 2 on denominator, so you have a radical 3. The ratio radical 3 over 2 divided by 1/2 is radical 3. Okay, that's from the numerical perspective. Okay, from the graph you can see that as well. Okay, so we got this point. X is pi over 3, you have a value y is radical 3. You may go back one frame. That's when x choose value pi over 4. 180 is pi divided by 4, you have a 45 degrees here. And corresponding to the length of the arc, which is pi over 4, okay? And then from 0 to pi over 4 is this part, red part. That's the length of the arc. From 0 to pi over 4 equals this part. Length of the arc is used to measure how big this central angle is. So when x is pi over 4, the tangent line is actually 1. from 0 to this height. This will be value y. Okay? You know, from this unit circle, you may also see this angle 45 plus this angle 45 is 90. This is a right angle is 90. So together, all of 3 is 180. 45 here, 45 here, and then equal angles correspond to the equal legs, equal opposite side. If here is 1, here will be 1. Radians is 1. So this leg will be 1. This again, 1 squared plus another 1 squared is 2. So this hypotenuse will be radical 2. Radical 2. Okay, because radical 2 squared is 2 plus 1 equals 2 is 1 squared plus 1 squared. Okay, so this length is actually radical 2. Okay, so then you will have a 1x is pi over 4 or 45 degrees. You have a radical 2 over radical 2 for sine divided by radical 2 over radical 2. This radical 2 over radical 2 is for cosine. Sine over cosine, they have the same value. Radical 2 over radical 2 divided by the same value, you get 1. Okay, so that's why from the numerical perspective, from the definition of the ratio perspective, you then have a 1 as well for the value of y. Okay, so that's the value for pi over 4. Keep going one more. Keep going back. One more frame. And then you will see this angle is 30 degree. Is again 1x is pi over 6. Pi is 180 divided by 6 is 30. So when this angle is 30 degrees or pi over 6 radians, again, this length of arc is pi over 6, which equals 0 to pi over 6. This line segment is pi over 6. Then the value you have will be radical 3 over 3. Okay? Yeah. So this height is radical 3 over 3. Again, that will be what? 1/2 divided by radical 3 over 2, which is 1 over radical 3. It's because you cancel these two denominators. You have a 1 over radical 3. 1 over radical 3. 1 over radical 3, both numerator and denominator multiplied by radical 3. You rationalize this denominator, you have a 3. And 1 times radical 3, you have a radical 3. That's why I mark here is radical 3 over 3. And here I keep the ratio as 1 over the other. Okay, so here's how we got the tang pi over 6. All right. Now, you may keep going back. Keep going back. You may keep going back. You look at this point. Okay. If you look at this point, this is 0. Angle is 0. Sine 0, y coordinate is 0. Cosine, you have a 1 here. X coordinate. And then 0 over 1, that's 0. Okay, 0 over 1 is 0. So you have a tangent 0 is 0. So that's why at this point, you plug in 0 here, you have a value y, which is the ratio of 0 over 1. so you have a 0. Okay, so tangent 0 is 0. So 0, 0 is on the graph. Okay, you may keep going back. Okay, here actually I add one more points here, but not on the table. So you then consider pi over 6. Because here this one was the half of pi over 6. Okay, so that will be pi over 12 negative. Now, here is similar to what? To the case like that. One is you choose pi over 6 positive. Another is you choose negative pi over 6 for the value x. Okay, so point it right here. Okay, so numerically, you will see sine negative pi over 2, sine negative pi over 6 is negative 1/2. Okay, and then you have a cosine negative pi over 6 numerically is x coordinate, which is radical 3 over 2. And then the ratio of those two is negative 1 over radical 3. Again, you rationalize this one. That will be negative radical 3 over 3. So again, is 1 times radical 3, you have a radical 3. Radical 3 times radical 3 here, you have a 3. So here is negative. Alright. Similarly, you can play with negative pi over 4 for this one. And negative pi over 3, which is negative 60 degrees, you have a negative radical 3. Here, then, you know, from negative pi over 3, that's negative 60 degrees. Okay? So then you go like that. All right. So this is actually you did from negative pi over 3 to the positive pi over 3. Let's consider pi over 2 at this point. For pi over 2, that's basically the point is right here. We know here is, this point is 1, 0, and this point will be 0, 1. So sine is 1. Sine pi over 2 is 1. Cosine pi over 2 is 0. It's because this point is 0, 1. Then 1 over 0, 0 cannot be on denominator. So that you then get tangent is not defined when x is pi over 2. This is 1. This is 1. 0, 1, this point. X coordinate is 0, y is 1. X coordinate is 0. Y coordinate is 1. Okay. So then 1, this is sine over 0, though it's not defined. Okay. Similarly to this one at negative pi over 2. So when you have 2 points, one is here or here, you will not get tangent x is defined. It's because x coordinate is 0. X coordinate is defined for cosine. So when cosine is 0, then tangent will not be defined. It's because tangent is sine over cosine. Denominator cannot be 0. So it then tells us what? Any point right here, any point right here, it will not be defined for tangent. Okay? So, if this is pi over 2, we do that. You add pi, it goes to here. And you add another pi, it goes to here. So what is the domain then for tangent? Tangent cannot choose 90 degrees or negative 90 degrees or anytime you add pi. So here that's why this is the domain. This is the domain. Okay, x cannot be 90 degrees plus any k times 180 degrees. This is expressed in radian. The one I read is in degree. Okay, so that's the domain. Now, how about range? Okay, domain is from negative pi over 2 to the positive pi over 2, but those 2 points are not included. One is the one here. Another one I did not mark is negative pi over 2. All right. Okay, now how about the range? Range, it can be as big. Y can choose value as big as you want it. You see, it goes infinitely down and infinitely up. Okay, and down here you get another branch. If you choose the ratio, let's say 5 pi over 6, sine 5 pi over 6 is 1/2, and cosine 5 pi over 6 is negative radical 3 over 2. Then the ratio will be 1 negative radical 3 over 3. Or you may say 1 over radical 3. So basically, tangent x has a period pi. You see, from negative pi over 2 to the positive pi over 2 is one period. And then from pi over 2 to 3 pi over 2 is another period. This is to the right. To the left, you also have another period. So tangent graph looks like that. Okay, looks like this. Again, at this point, it's not defined. All right. Yeah. So that will be the property for tangent x. Okay. So the domain is not included at those places. Range can be any real numbers. And the period is pi. Okay? I'll see you next time.